This presentation is called Faster Than C, Parsing Binary Data in JavaScript. A little bit about myself. My name is Felix, and I actually have a connection with Atlanta. I was here in 2004, 2005 as a foreign exchange student at Grady High School. And I just had the greatest time here. I met a lot of good friends, and the host family I was staying with is really awesome. So every time I can come back, I do. So I've been pretty much back in Atlanta once a year since then. So I like Atlanta and the people here. What do? I do a bunch of things. I do Nodecopter. Has anybody heard about Nodecopter before? Most people haven't. So Node. That was we were supposed to have. That was the one I screwed up. I'll not talk too much about this, but so for those who don't know what this is, basically last year in Berlin we kind of did a pre-event to another conference called JSConf.eu, and we decided instead of doing another like lame presentation like this where I'm just going to do a lot of talking, we want to have people program flying robots with JavaScript. And we were able to get sponsorship, buy a lot of robots, get a lot of people in this old abandoned kind of pool thing. And they were doing computer vision stuff, image detection, all kinds of interesting things within a day. And they had never done it before because we figured out how to make it really simple and easy with JavaScript. So it kind of took off, and there was more events. And we were trying to put this thing together called the Summer of Drones, where we would buy a whole bunch of drones with sponsors and have kind of events all over the place with the help of local organizers. And Wesley and I were actually going to put on an event here in Atlanta, but we screwed it up. We basically took too long time to prepare, and the sponsorship didn't come in time to place the orders. So it happens. So instead of flying robots today, we're going to talk about something else, but hopefully it's going to have some practical value. So the C talk is about performance. It focuses on a little story I had with JavaScript performance, but I think the lessons from it are actually applicable in general. A few other things. I run a company called Transloaded. We do file uploads and video encoding as a service. So if you need file uploading and handle files, we do that stuff. I'm a Node.js core contributor, so I was one of the first contributors. I did a lot of patches initially, because when we used it, Node was not really working for us, and we just had to contribute quite a bit. So I know the Node core pretty well. And I maintain a few modules that are popular in the community. This presentation is a lot about the work I did for the Node MySQL module, but I've also done Node Formidable, which does file uploads, and I have a bunch of really small modules, a whole bunch of them. And, oh, I need to say one thing. I actually have, it's a little blasphemous, but I've kind of converted away from JavaScript recently a little bit, and I'm doing a lot of Go these days. I'm not going to talk about Go, but if you want like the Go sales pitch after this presentation, just hit me up at the bar. That's a good one, by the way. Anyway, I'm going to say stupid stuff. I always say stupid stuff. So if you want to correct me, best come to me after. But if you just want to tweet out, this guy's stupid, that's my Twitter handle to do that. And so let's get this thing started. So this talk is about performance. And it kind of compares the performance of JavaScript to the performance of C, which is comparing good versus evil. We can argue which one is good and evil, right, with JavaScript versus C. But we're also going to talk about using the good parts against the evil. And it turns out we may also need the bad parts to fight evil in this case. And I'm just being facetious about C being evil. It's just a fun thing. But first of all, am I really going to claim that JavaScript these days is faster than C? I'm not going to do that. This is a title bait. I'm sorry. However, what I will claim is that JavaScript these days can be as fast as binding to C for getting some particular performance work done. And by that I mean, if you have the choice of using a module written in JavaScript that talks to a network thing like a database and has a binary protocol, and you need to decode that binary data into JavaScript objects, I believe that these days we can actually make that binding either by taking a C library and binding that into Node.js, or we can write the whole network protocol and the whole decoding in JavaScript, and the performance will actually be comparable. And that's possible thanks to JavaScript being very fast. However, it still involves a lot of work, and that's kind of what I will talk about a little bit. So there's a story to this. And the story is kind of that in early 2010, the Node.js community had a problem. And the problem was that MySQL was very popular as a database, still is pretty popular, but there was no MySQL module for Node.js. There were actually no SQL modules for Node.js, but not MySQL. And so a lot of people were worried about this. Ryan Dahl, the creator of Node.js, was like, oh my god, what are we going to do about this? In other languages like Ruby or Python, people were just always binding to libmysql. And that was fine, because these languages are blocking. If you call a function from libmysql, you expect your program to hang in there until the database server replies. However, in Node, you don't want to do that. In Node, you want to do asynchronous I/O. And this is not really possible, because libmysql is essentially blocking and single-threaded. So it was a problem for a long time. I'll spoiler ahead. We figured it out eventually in the Node core, and they basically created a thread pool where stuff like binding to libmysql would be parked in a thread, and then you would just have multiple threads to do this stuff. So that eventually was solved. But back in 2010, we were worried about how this would work. And then there was this guy. I can't pronounce his Japanese name, but his Twitter handle is Masui Trive. And in like this super polite Japanese way, he sent a message to the Node mailing list, actually contributing a patch to the Node core. And then like in a little paragraph at the bottom, he was like, oh, by the way, I don't know if anybody will be interested in this, but I started writing this module that talks to MySQL. And basically, I just wrote this in JavaScript. And everybody was like, what? And checked it out. And so I was also looking for something that talks to MySQL. And so I checked it out, and I realized that guy had done it in pure JavaScript. He had not used C or C++ to do binding. He just re-implemented the MySQL protocol. And that was crazy. And actually, Ryan and I and nobody else in the Node community really thought that it was a project you could pull off, because it's kind of a complex protocol. It gets even more crazy. In Node, we have this thing called buffers, which are essentially an array of bytes holding binary data, like a C memory slice. And he did that work before we even had buffers in Node. So his parser was actually using JavaScript strings to decode the binary MySQL protocol and makes this work. That was crazy. This guy was good. Anyway, how many of you guys have used Node.js before? OK, that's enough people. So a little bit of Node.js trivia to make that relevant. Buffers in Node actually used to be called blobs. And I really regret that they're not called blobs anymore, because buffers as a word are also used for buffering data. And it's not always clear if you're talking about buffering binary data or buffering strings into an array. So I think blobs was a much better word. And they were actually called blobs for 3 minutes and 15 seconds. And then Ryan changed his mind and did a commit to revert the name and change it to buffers. So I like to remember the blobs. I had a short life, but it was good. Anyway, so the big revelation from Masui Trive's work on the MySQL driver was that MySQL can be done without libmysql. We can actually pull this off and write a JavaScript library that decodes the binary protocol. Unfortunately, however, he didn't really continue with this work. I think he got backed up with other stuff, and he just left his libraries there. Meantime, we got buffers into Node.js, so we had a much better way to address binary data, and his module kind of needed a complete rewrite to make sense anymore. And I was like, well, he's kind of proven that it's possible, so why don't I look into this? Because I still had this problem, and I needed something. And well, this is embarrassing. But my solution up until that point was to actually have a PHP process running in the background that I did IPC with and use PHP's MySQL binding. And I'd send like JSON data back and forth. It was terrible. I don't recommend this. But I was desperate. So anyway, so I basically went ahead and decided, OK, I'll do this. I'll create this from scratch. And since he's not updating his, I'll just steal his name, because the name is Node.mysql and makes sense. And he was cool with it. And I basically also implemented the entire protocol in JavaScript. And it turned out OK. I think most people in the Node community use it. It's the most used MySQL module. And we're also going to talk about the performance benefits or disadvantages of doing it this way. That being said, if I could go back in time and wait for somebody to do binding to libmysql, I would do that. This was a lot of work that was just me being interested in the problem, really. Anyway, so publishing this thing on GitHub. The universe is like the universe is, so no good deed goes unpunished. And I believe that the guy who actually came up with this concept was this guy, Sir Isaac Newton. And he was a scientist, so he used fancier words. So he called it the third law of motion. And what the third law of motion says is when a first body exerts a force F1 on a second body, the second body simultaneously exerts a force F2 equals minus F1 on the first body. That means that F1 and F2 are equal in magnitude and opposite in direction. So here's the thing about Newton. Newton was amazing. He did a lot of interesting work. But he was also very secretive and very competitive. He never gave Leibniz any credit for also coming up with calculus. He was like, mine, I did that. And he did not really share his stuff. And I think the reason for that was he was born in a time where there was no GitHub. So with GitHub, he would just put his stuff out there, and we could see when the first commit was made, right? It would be verified with the SHA-1 hash. It would be great. Anyway, so let's imagine that GitHub was already around for Isaac. So I think he would have come up with this bullshit. This is just me being very bullshitty. It's the third law of GitHub, which is maybe phrased like this. When a first person pushes a library L1 into a remote repository, a second person simultaneously starts working on a separate library L2, which will be equally awesome, but in a different way. That's why we love GitHub. That makes GitHub great. Somebody does something great, somebody comes like, I can do you one up. And that's what happened to me. I did all the work on the MySQL module, and then this guy comes along, Sanis. He basically created a binding to libmysql. Once we figured out the thread pool stuff, we were like, OK. He was like, this makes much more sense than doing all that work again. So he did a binding, and he released it. And well, being the, like, developers are always competitive about things and performance, so he did some benchmarks. And he was like, mine is so much faster than yours. I was like, let me see that. So I ran some benchmarks of my own. And so it's not really relevant, but if you're interested in the details, the benchmark I was mostly obsessing about was the use case of having a lot of data from a lot of rows in MySQL coming in. So the typical use case would be like you kind of import 100,000 rows from an existing database. You want to convert them and then push them back up in the database, like kind of a migration thing. So in this case, 100 megabytes of data containing 100,000 rows. The rows would have 5 columns, ID as an auto-incrementing integer, title a varchar, text as a text, and created and updated as state timestamps. And conceptually speaking, the work that driver for MySQL has to do in this use case is it has to create 100,000 row objects. And each of these row objects is going to have properties for each field. So you end up with 500,000 keys and 500,000 values. That's kind of the work we're looking at. And so he was claiming his was faster. I did my own benchmark, because you can't trust other people to do it. And this was the result. My library's on the left. So yes. His library was slightly smaller, shall we say, easily by a factor of 2 or 3. And when I saw that, I was like, well, of course. libmysql is written in C. And my stupid little thing is written in JavaScript. And C is faster than JavaScript, right? And I would get really desperate, and I was about to give up. But then I was like, wait, wasn't this V8 thing supposed to be super fast and turn my JavaScript into assembly code? And wasn't there this thing called Crankshaft that would analyze my JavaScript code at runtime and generate even better assembly code by figuring out the types? And wasn't Node.js going to solve all my performance problems anyway and cure world hunger and whatever? Was I living a lie? I felt unhappy about this. And so then I did a lot of stuff. And my conclusion is, well, I was actually kind of living a lie. Because V8 and Node are tools. They may be fast tools by default, and they may have interesting performance characteristics. But turns out performance is actually not a tool. I don't know what performance is exactly, but it's not a tool. And from my experience, it's a lot more about hard work and data analysis. So actually, I sat down and I was like, let me see if I can do this faster. And so I basically rewrote the library. And I had this great idea of how to make it faster. Well, it turns out the rewrite was 1,000 times slower, because my idea was fancy and I didn't verify data early on. So I was like, well, that was not a good idea. Doing everything from scratch and benchmarking at the end, that's not really good. So I redid it again. And so at the end result, I got something kind of fast. But it was a lot of hard work and a lot of data analysis to actually get there. In fact, I poured maybe 150 hours into this thing. But anyway, the end result was that I got a library that performed better. And this is kind of the result. My first version is on the far left. In the middle is the C binding. And on the right side, there is my MySQL version 2, which, as you can see, is easily as fast, maybe a little bit faster. The bar is a little higher. But I don't know if that's significant or not. But we're competitive, right? So I was really happy with myself. And at this point, I was like, man, this is so cool. I have to submit this to a great conference like JSConf EU and like talk about this, because, man, this is good. Well, remember that third law of GitHub thing? It hit me again. And in between submitting the presentation, I got accepted. And after getting accepted, this guy comes along, Brian White. he does another binding to a C library. And he was doing a binding to Maria SQL. Maria, if you don't know, is a fork of MySQL, and they also forked the client-side code. It's actually by the original guy who started MySQL, Monty. And they forked the client-side code, and they actually made the MySQL client non-blocking, so also doing asynchronous I/O. And Brian is also a very smart guy, so he made a better C binding as well. So you combine these two things, you get performance again. So he, again, released performance benchmarks with like, mine is faster than yours. And I was like, man, let me test this. So I had this benchmark going already, so I plugged it in, and this was a new result. So yeah, I don't need to say a lot about this. I was devastated. So what would you have guys done? Would you have given up at this point? Raise your hand if you would. All right. I was about to do it, but then I was like, never going to give up. And so I, again, set out to create another parser. And I basically, and I'm going to talk about what I actually did in just a little bit, but I basically did everything from scratch again, put even more work into it, worked on it really hard, and this is kind of the end result. And by end result, I mean, I actually just did this for fun. I never actually integrated the faster parser in the current library. I just wanted to see if it's doable, and then didn't finish it. Anyway, so the thing is, I wrote this new parser, which is twice as fast as the previous one that I had in the MySQL 2 version, which puts it about on par with the performance of the Maria SQL thing. They should be in the same ballpark. And so I'll talk about how this happens in a second. But before, what's going to happen? Is it even worth putting in, or is that third law of Github thing going to hit me again and again and again? Actually, I think this time around, I have good reasons to believe from the data that I analyzed that this is kind of approaching the endgame. And by endgame in this case mean that the last bottleneck becomes V8, the JavaScript engine itself, and creating JavaScript objects. And it doesn't matter if my decoding happens in JavaScript or in C. At some point, both of our libraries have to ask V8 to create a JavaScript object for me with all the properties for all the keys and all the values for all the values. And it doesn't matter if I call this function from, like if I do that in JavaScript or I call the C++ interface to V8. That work has to be done. The garbage collector needs to take care of it and needs to track it and do the garbage collection. And by the time that the encoding just becomes ridiculously fast, this is kind of the limiting thing. And I believe I reached that point from the data I have. Also, it's just for fun at this point. The MySQL server is horribly saturated at this point. When you have a single client that can do 6,000 megabits of data retrieval from a MySQL server on a single CPU, you're probably going to saturate whatever MySQL machine you have. Chances are you may still have a 1 gigabyte network interface, in which case you've exceeded the network interface. But even if you have more, as soon as the disk gets involved, you're not going to get this kind of data flow coming from a MySQL machine. So I think we were at a point where it's really pointless to optimize further. Anyway, so let's turn this talk into something useful away from the story. How can you actually write fast JavaScript? And some of this advice, I hope, applies to other languages and technologies as well. So the first thing that I want to talk about is what doesn't work. And, well, I'll put it in context. But basically, for what I was doing here, to get really to the last levels of performance, profiling stopped working for me. Profiling is neat when you've written a whole bunch of code and you kind of want to know what's slow. But profiling just tells you what functions are slow. Profiling doesn't tell you how to fix it. It gives you no clue on what you need to change. Now, sometimes it's an easy fix where you're just using an inefficient algorithm and you're doing unnecessary work, and then you stop doing the stupid stuff and you get fast. But when you're already thinking you're pushing the limit and you have your data structures well sorted out and all that stuff, profiling doesn't really get you further. What else doesn't work? Taking performance advice from strangers. And I am a stranger. You should keep that in mind. So taking performance advice from strangers is good for ideas and inspiration, but it's useless when you apply it cargo code style. And I see a lot of people do this. They take advice, maybe some stuff that I'll say, or some stuff that the V8 people who really know what they're saying will tell you in terms of this, do this and your JavaScript will be fast. Well, they then just take that knowledge and they apply it in all kinds of situations where they believe I need fast. However, they never verify their assumption. And by that, I don't just mean that the optimization will make things faster, but they will not verify that it will make it faster for this use case. It really matters if you have a loop that's doing 1 million iterations per second or 50 million iterations per second, what you're doing inside this loop. Some stuff you do at 1 million per second you can do the slowest thing ever inside the loop, it doesn't make a difference. But at 50 million, it may make a difference. So it really depends on how hot your loop is to judge which kind of advice applies. And unless you test it in the actual context of what you're doing, applying all these micro-optimizations will get you nowhere. But they're good for inspiration. I'll just give you a stupid example. So a lot of people will send me patches every once in a while where I have a for loop that looks like this. And they'll be like, don't you know that you can make for loops much faster? Can't you just do this, where basically you cache the length lookup, so you don't need to access array.length for every iteration? It will make things so much faster. And I actually receive pull requests where people do that in context where it doesn't matter. And well, there's a bunch of problems with it. First of all, sure, maybe there's a situation where this makes my code faster, but unless you can show me the benchmarks that's relevant, why should I do this? It makes my code weird. The second reason is, these days, actually, the JavaScript engines are optimizing this away. I think this use case no longer applies. It used to be an optimization that was useful in some situations. And yeah, that's pretty much the example that I have there. And there's a lot of other like micro tricks. A lot of people are obsessed with this JS perf tool where you can do all these micro benchmarks, and they'll paste links on Twitter, and everybody starts doing it. That's not good unless you test it in context. So what does actually work? You're not going to like the answer, but it is the answer. Benchmark-driven development. And benchmark-driven development is basically similar to test-driven development. And I should state that just like test-driven development has the most value when you care about correctness, and there's cases where you don't. You just want to get the prototype out of the door. Benchmark-driven development is only interesting when performance is an explicit design goal. And by that, I don't mean it's like the 10th thing on your list of requirements. It's like the first thing. And that usually shouldn't be the case. So it's an exotic use case where you just want to play with some people on GitHub for the stuff I was doing. So the whole idea behind benchmark-driven development is if you start benchmarking early on and you do it all the time continuously, you're going to write code that is much faster as if you just write a lot of code and then try to benchmark it and then try to make it fast after the fact. I've tried both paths several times, and I found that if I always care about performance continuously as I work on the project, I get much better results. So how do you do this ideally? So the way you do this is you start with a function. And the function is the work you want to do, your benchmark. And you just put a bunch of code in there. And that code should ideally be slow enough that it takes a few milliseconds to run at least, maybe 100 milliseconds. So if whatever you're testing is not by itself slow enough yet, just make a for loop that's long enough. Just get enough iterations in there. Because when you do, you can do a very simple benchmarking tool. Here's my tool of choice. And I've done a little bit more sophistication, but this is enough to get you started. So you do an endless loop. You take a timestamp when you start. Then you call your benchmark function. The thing's going to take a few milliseconds to run. Then you get the duration, and you print that out. Easy as that. So how do you continue? So next steps that you do is you implement a tiny part of your function. Basically, just the least amount of useful work that will get you closer to solving your problem. And in my case, it was basically parsing the headers of a MySQL package, which are the first 4 bytes that I get in. And the whole package may be hundreds of bytes. So I just cared about these first 4 bytes and ran the benchmark against the code that parses them. And then what you do is you look at the impact of adding this functionality. How much slower did I get versus essentially doing no work or very little work? And then you start tweaking the code. So this is actually the part where you can remember the stuff that people have told you could make your code faster. You try these things out, but you're trying them in context. You know that this is actually the stuff I'm testing. And then you tweak the code, and you do that often enough until you find a good improvement. You pretty much in most cases will find an improvement. And what you're going to learn from this is that a lot of your assumptions don't hold within your context. So I'll give you examples, and you need to promise me to forget them for your code. But in my case, I was under the impression that as soon as I wrapped something in a try-catch block, it would get slower. Because people had shown that this was the case in some JavaScript engines for a long time. And I had this in the back of my mind, and I was trying to avoid try-catch. Well, it turned out for my use case, didn't make a difference. And wrapping a function that I was benchmarking in try-catch didn't make a significant difference. So that made it easier to get the code written. Another idea I picked up from somewhere, I looked what other people were doing for parsing these network protocols. And I saw a lot of these big state machines using a big switch statement. And I thought, well, if they're doing it, they really know what they're doing. For example, Ryan Dahl did that for the HTTP parser that powers Node. They must know what they're doing. So I just copied that stuff. Turns out bad. V8 actually doesn't optimize that use case. I think they maybe have a patch by now that does it. Anyway, the reason why I was also attracted to that big switch statement in my design was I thought function calls would cost me. I thought if I do less function calls, my code would get faster. Well, wrong. The function calls are so fast these days that the benefit of having them in there to structure your code better makes a much better code base, easier to get your stuff going. It also makes the profiler more useful because the more fine-grained functions you have, the more it can actually tell you. Even though it may not tell you what to change, you get a more local idea of where the problem is. And probably the biggest revelation I had that buffering is actually OK. In the Node community, there's a lot of idealism around the idea of not buffering data, of streaming everything. So when you parse something, you just parse enough data that you can emit an event, and then the next guy handles it. So in my initial design, I was actually trying to parse as little data as possible in the MySQL parser and emit events and kind of put them together at a higher level. Actually, it turns out it's a stupid idea. You need to do more bookkeeping to do this. So buffering up a whole bunch of data and then going through it in one pass, much faster. I also came around some creative ideas. The one optimization that I actually ended up using was loop unrolling using eval. Eval is basically a way to evaluate any JavaScript code at runtime, but it has a good twin, which is called new function. And you can actually make that work securely if you put your mind to it. Wouldn't recommend it for most code, but here's basically the idea. I had this kind of part in my code called parse row. And in parse row, I get a few arguments, my columns in the parser. And then I basically iterate for each row across all the columns, and I attach basically the property of the row to it and read the value for this row from the MySQL data that I've already buffered. So I'm saying row columns I.name equals parser.read column value. This turned out to be a significant bottleneck in what I was doing. And I was playing around and back and forth, and how can I make this faster? And then I was basically just hand unrolling this loop to see what an impact it would make. And I wrote this. And it turns out JavaScript engines can handle this much, much more easily because they get a better idea through static analysis of what the shape of that object will actually look like before they have to hit it at runtime. So V8 was able to run this much better. So how can I unroll this loop at runtime? Basically, I did a little hack like this. I said, I'm going to generate that code at runtime. I'm going to generate a function. And for each column, I'm basically going to generate the code to parse this column. And then I end up with basically the exact same unrolled code that I was just showing. Never do that for anything you really want to do. But this is the part where, I mean, if you want to be competitive with C in JavaScript, you'll have to go this far. There's no other way. Actually, I think this particular use case V8 engine could optimize, but they just have a long list of stuff to work on. So anyway, this is kind of the specific examples. Before I go into the other stuff, please do not remember any of this. Do your own benchmarks. Do the stuff that matters in your context, because it turns out it's really different stuff for different use cases. It depends on how hot your loops are, what data structures you have. So the next thing I want to talk about is data analysis, because I'm a little frustrated with the way that some tools do this currently. Basically, here's how you do really good benchmarks. Write a script just like this while loop that I was showing earlier with the console log, and then produce as much data points as you can for this particular benchmark iteration, and just output them to standard out using tab separation, or I don't know, use commas, whatever. But basically just do like the Unix way of outputting this data on a line-by-line basis. And what else do you output except for the runtime? Well, anything you can get your hands on, especially metrics from the VM. What's your memory usage? What's your garbage collector doing? All these things plug in there. Also store in what Node.js version you were using, what stuff was involved, so you know that when later on somebody looks at the data, when later on somebody looks at the data, he can actually not only see the results, but also kind of have more context on what was happening. And here's the reason why I advocate this. You should never mix data from a benchmark and the analysis into one step. And a lot of benchmarking performance tools that I've seen utterly fail at this. They basically collect the data, and then without any step in between, without showing you the raw data, they just show you the result. Like JSPerf, for example, does exactly that. Many benchmarking tools do that. And there's actually a huge problem with doing this, because if you don't have the raw data, you're only going to look at whatever visualization they're going to provide from it. And it turns out you actually need to look at the data in many ways to really understand what's going on. And I have an example on this in a second. A few recommended tools on this. So as I said, output the stuff to standard out. And then you can use Unix utilities, for example, T, to pipe the data into a file and also see it on your screen at the same time. I'm a huge fan of using the R programming language. Who has used R before? You guys should all check it out. It's It's a terrible language, but it's the most powerful visualization thing we have. It's a statistical analysis tool, especially when you use the ggplot2 library. You get very interesting, nice graphs with it. So use that. It's really good, and it can parse these tabulated value files really easily. And then you can use stuff like makefiles and image magic, and I use Skitch to do some annotations, to do some of the tooling in between, automated, kind of generate images from the PDF, all these tools. So let's look at the why. Why do you need to separate data generation from benchmark from the analysis? So let's go back to this. What we have right here is a benchmark where, in my latest iteration, I compared the fastest parser I was able to write with the previous version. Well, I was looking at this data and was like, OK, this is interesting. A is faster than B. Well, great. B must be great. But then I was like interested, well, how is the distribution of this value actually looking at? So I did a jitter plot. And this is what the jitter block looked like. Basically, on the left side, I have my somewhat slower library. And on the right side, I have the faster library. But what's this? What is these gaps here? Like, why is there like some data points where the parser in some iterations is really slow, and in some it's really fast? There's a huge gap in here. It's about 10% or something. And so I was like, well, that's kind of awkward. And so I actually started plotting this data over time. Or actually, this is the iteration of the benchmark. And this is really interesting. Not only do both of these have kind of these huge gaps in the distribution changes over time. So initially, both parsers start out fast. And then after the same amount of time, actually not time, it's iterations. So it's the same amount of data parsed. They both drop in performance. And they're completely different code bases. I mean, I wrote both of them, so it's a chance I made the same mistake. But man, this is a pretty weird pattern to see from my performance. So I was like, what's that? So good thing I actually used the separation between data logging and data analysis, because now I could drill down further. I also had the virtual machine metrics for this. So I was able to look at the heap total usage. So how much memory does V8 get from the operating system to place JavaScript objects in? This is not necessarily the amount of memory it really needs. It's just the stuff that it kind of reserves for placing objects in. And what I see there is that both libraries, at the same point in the iteration where the performance drops, right here, at the same amount of iterations, the VM memory usage goes up from like 20 megabytes to 35 megabytes for heap total. Interesting. So I looked further. I looked at the actual heap used. And heap used is the amount of actual living JavaScript objects that are in the heap at any given time. And as you can see, this goes up and down for both libraries. That's a garbage collector doing its work. But as you can see, at that exact same time spot, the VM basically takes more of a heap total and then ends up for each iteration running the heap total to the maximum, doing a garbage collection and running back down. So what do we have here? Well, turns out we have a V8 bug. The garbage collector is actually not doing the best thing. Because initially, it was doing that work much more efficiently, and then at some point, it just starts doing it much more inefficiently. Even though I don't leak memory, I'm not allocating more stuff. It's the same runtime profile. So the good news is, by doing this work, doing the data analysis separate from the data logging, I was able to actually get good data on this and submit it to the V8 guys. So the bug is kind of fixed now. And by kind of, I'll show you what I got when I did this benchmark again today. This is basically the profile that we had in Node version 0.8.22. So there's a number of iterations, 100 iterations or something almost. And then there's this 10% performance drop. And it's the same for both libraries. And here's what it looks like in the newest Node version. Interesting, to say the least. Two different code bases that previously exhibited the same garbage collector bug now have a different one. So the faster library, well, first of all, actually, I can't bitch about the V8 people. This thing just went from, what's the top here, like 7,000 megabits in the top profile to up to like 9,500 megabits per second. That's a nice improvement just by upgrading Node.js. So I'm not really complaining. But they still have the problem where for some periods of time, the performance drops, and then it gets faster again. For a short amount of time, performance drops again, goes faster, drops, whatever. Interesting. For the older, like not so fast library, the pattern is not that clear. It's not going that much up and down. It's basically dropping again at this point, and then, well, kind of shitters around, but doesn't go back to the full value again. So what can we learn of this? First of all, virtual machines are fucking magic. There is no way in hell you're actually going to get a good mental understanding of how these modern virtual JIT machines work. Your best chance is to actually do a lot of benchmarking, collect a lot of data, and look at what's really happening. You may still not understand what is happening, but at least you have something where you're like, OK, at this point, it's the virtual machine's fault. I'm done with my work. Now I submit this to the virtual machine people. And yeah, So more summary. Too long, didn't read. Write a benchmark if you want to make something really fast. Write a benchmark, then write and change a little bit of code. Collect as much data as you can for this iteration of the benchmark. Find some problems with it, like come up with new ideas, change the code again, then go to 2. And that's pretty much it. Thank you. Are there any questions?
Oh, it's just me? OK. So this kind of stuff, I mean, performance tuning in general will make you a little loopy. And you have to have a very specific reason to do it. So, and it seemed like yours was just competition.
Yes. I mean, there's this imaginary use case where somebody wants to migrate a lot of data, where this optimization was benefit from. I did not actually have this problem. I was just.
But not a real use case.
No.
OK. So can you talk about the point where you like doubled a couple times? So you just scrapped it and rewrote it?
I scrapped it and
I would normally like, benchmark a little bit and try to figure out where the spot was. But you scrapped it. Why do that?
Because the reason I did it was I was basically looking at something that was not fast enough. And I tried to write a benchmark for it, and then ask the profiler, hey, what's slow? Then the profiler tells me this function. I go into this function, and I start changing a little bit of stuff around. And I make incremental improvements. I get another 10%, another 5%. But I couldn't really make it gap to 2 times. And it actually turned out I wasn't doing anything particular that was really stupid, except for the last use case where I did that eval thing. That was, well, the eval thing was stupid, but it made it faster. Anyway, before, the first time I went through this process, I didn't do anything stupid in the first version of my parser. I just basically made a lot of small mistakes. And it turned out to be, for me, in my testing, to be more work and more frustrating to reverse my small mistakes, the sum of all of them, instead of redoing it from scratch and not making these mistakes to begin with. Testing kind of every line of code as I went along. It was easier for me this way. And I got better results. And tried both ways. It's practical. I'm not saying that's a theoretically sound approach.
OK.
Where do we buy your shirt?
This shirt actually Substack, James Halliday made, and he put it on Teespring, and I think he sold only a few of them. So you need to ping him on Twitter and be like, Substack, you need to make more shirts. No live coding, no. It's sad. I can live code something, I don't know why. I can write I could show you how to start with writing something like this, but I haven't practiced it, so it will be terrible. Unless you guys want to be bored a little bit, then I'll do it.
I was just wondering, by virtual machine, are you talking about the JavaScript runtime or like an OS virtual machine?
No, it's a JavaScript virtual machine, V8.
I was also wondering, how are you probing to find things like the heap usage, and how are you getting all that data?
So Node has an API called process.memory usage, I believe, is a function call, and that gave me the heap total and the heap usage. It also gave me the RSS, which is the amount the memory the operating system gives to the process. I did not find anything useful in there, so I didn't show it. But basically, all that stuff came from there, and I logged all of it away for analysis.
Did you have any problems with viewing those stats, altering the actual performance?
Viewing
those? So if I'm constantly asking for that process information, maybe it changes the behavior of one implementation versus another.
That's a good idea. I did not correct for that. I did not control for it. I suspect that it shouldn't change the behavior, but I should do a benchmark where I just leave out the process information and log the runtime performance iteration and see if it produced a different graph. I didn't do that. It's a good idea.
Can you give some sort of use cases of when to use Node over other languages for performance sake?
Oh, God. Now I have to rant a little bit. Don't use Node.js. 99% of the people who use Node.js buy it because it promises easy performance gains and, well, it's JavaScript and all that. But realistically speaking, if you can imagine a solution that requires, or that is a problem that is solvable using a relational database and Rails or a similar kind of framework with 1,000 of man years of experience in it, use that. You're going to have much easier time to develop software faster. When to use Node? You should use Node when you do exotic stuff. WebSockets, you just have a lot of WebSockets clients. Or you have that exotic use case where you may want to have code sharing between your backend and your front end. And so both are in JavaScript, so you can kind of pass the validation code around. But be careful with this. I heard a lot of people using that as a justification for using Node, didn't end up actually doing it in practice, and then all they got in exchange was callbacks. And I mean, unless you really have a concurrency thing and you want to use JavaScript for it because you're unwilling to learn something else, I actually really recommend Go these days for similar problems. I don't know. You use Go because it's going to take off. It's going to have a hype. You're going to get a job doing Node soon. I think it's going to go somewhere, but I don't think it's really appropriate for most of the problems people throw at actually. And I'll get a lot of shit for this, but I'll say it.
Can you elaborate on what do you mean by separate data analysis from what? From what?
Okay, so separating data analysis from visualization. Yeah, by that I basically just mean lock away the raw data from your benchmark, like which iteration of the benchmark it was, how long this iteration took in milliseconds, what the memory usage was at this point. Lock all of this data away into a file for each loop that you do in your benchmark, and then keep the data in a file separate, and then have another step that actually feeds the data into a visualization tool like R and visualizes it.
So those are generated by R, those graphs?
Those are generated by R, all of them. But yeah, don't use a tool that does both at the same time and doesn't give you the raw data, because you're limited by the visualizations that tool will offer, and you're going to miss stuff. At least I think.
You said something earlier that intrigued me. It was about the distinction between, or the not to avoid buffering, which I thought was strange, and just like rather than processing things as a stream, doing things as buffering. I was working on something earlier today where I ran into something similar to that, and I was intrigued if you wanted to expand a little bit more on that.
Okay, so buffering versus non-buffering. So there's one use case where you don't want to buffer up an entire data package that you receive from MySQL before analyzing it. And that is the use case where somebody has a smart idea of storing files in a relational database, because people have done it. In that case, you may get one row, and that row is, I don't know, 200 megabytes of data. So in that case, my database design kind of fails you because you're buffering that whole file into memory. And you probably don't want to do that, especially if you get a row with a lot of these files. But that, I think, is an extremely edge case of people doing stupid stuff with a tool that they shouldn't be doing. So optimizing all my parser design for that didn't make sense, because most of the rows I get from MySQL are like 10 kilobytes a row tops. And buffering 10 kilobytes of memory per row doesn't seem bad. And I do streaming on the row level, so you can get an event for each row. I'm not buffering all the rows up. But basically being able to buffer on the package level allowed me to write my parser in a much easier way, because I can literally have one function where I'm just saying parse the first 2 bytes and turn them into an integer, parse the next 4, turn them into a float. And I can just write this sequentially without having callbacks in between all of these. This means I need to do less bookkeeping, less callbacks, and can write cleaner code. And it gave me more performance and better code base. So in that particular use case, buffering was totally a good solution. But if you have another use case where you're really concerned about the data that's going to be in memory, do streaming. I mean, depends on the use case.
So in hindsight, would you use the C library instead of doing all this stuff?
Today?
Yeah.
No, actually, if I was, I use this in production, but if I was starting a new project with Node, I had to talk to my SQL database, I would use MyModule right now, not necessarily because it's a good idea to do this in JavaScript, but MyModule has been battle tested. So there's actually been hundreds of people using it in production successfully, submitting lots of bug reports. I have about 5 or 6 people on GitHub helping me maintain it, whereas the other C libraries didn't gain any traction. Not because they're bad, they just came too late. And people already, well, there's another reason, Windows. Getting any C add-ons to compile on Windows is a huge pain in the ass. By using something that doesn't require a C compilation step, people know that the portability is better, and they may choose that in certain team settings. So there's some benefits, but if I could go back and invent a C solution first, I would. Yeah.
JavaScript Perf is kind of the end-all, be-all. So I'm wondering, like, is there something that is as easy as or as fast that I can kind of say, like, in any situation, let's take a look?
So you're asking if there's something that will have the features like JSPerf that you can just apply to a problem you have? Or is that?
Sure, like the while loop you set up, or whatever. Like, is that simple enough that you can say, like, let's run this here, it's one instance, instead of just like checking out JSPerf online?
Well, it depends. If all you want to do is this micro benchmark to really find out which micro optimization makes sense, use something like JSPerf. But before you go and apply that micro-optimization in your actual problem domain, you're probably going to have to set up a benchmark. Well, it also depends. If it's a Node project, JSPerf is not going to give you the Node API, so you can't use it. If it's purely a front-end thing and you can conceivably put the full thing into JSPerf, you could still have the problem that it's not going to give you the data analysis. It's not going to show you the distribution of points. But I mean, as I said, I wasted 150 hours on this project. It's not very reasonable for most real-world use cases. So if you just need to get an idea if something got faster or slower real quickly, do it. I mean, just throw it into JSPerf if it solves the problem. Use appropriate tools at the appropriate time. Sorry if I didn't make that clear.
I'm just curious, it's a little off topic, but you were saying that you use Go for the appropriate things. What are the appropriate things?
Oh, also super niche. There's not a lot of problem I would use Go for, but like in the problem domains where I see Node being strong, which means WebSockets, high concurrency stuff, I think Go has a lot of benefits. Basically, you get static typing, but with basic type inference, so it's not as annoying to use as Java. Go plays a lot into what Java could have been and what C++ should have been. So Go kind of tries to retackle that problem. It's also good when you need a static binary. So it produces one static binary and cross-compilation is great. So for example, if you want to write a little tool that you can deploy to servers across platforms, and that just runs there, really good. High performance-wise, Go becomes very interesting these days because it tackles a multi-core problem that Node doesn't really address. So in Go, you can actually say, I want to distribute this problem on 8 cores, and it's going to use all of them, where in Node, the only way to really tackle this is by starting 8 node processes and either having no state in between them or sharing the state. You can kind of load balance over file descriptors as far as incoming connections are concerned, but you're not going to get the shared memory, and sometimes you want it. And Go solves basically the callback hell by allowing you to do blocking I/O calls. And whenever you do a blocking I/O call, it kind of yields back to the scheduler. So the operating system thread gets freed, and it can use another, they call it Go routine. It's green threads, and run that Go routine on the same operating system thread. And so you can literally have 100,000 threads running, but you're not going to use operating system threads. You're going to use green threads, very low resource usage. And in terms of shared memory access, you get channels, which allow you to pass data structures between these, like kind of message passing. It's a lot like Erlang, except you don't get to create the exceptionally great error handling Erlang has. But you get a lot of the ideas from Erlang in a language that is surprisingly easy to learn and easy to use, and very consistent. It's very modern, and it's stable. Go is at version 1.1 now. Go is still at version 0.10. They've kind of outbuilt Node in terms of building a stable platform. And I actually see a lot of adoption for Go. So check it out if you have an exotic use case. If you're just going to build something that takes database data and turns it into HTML, use a tool that's really specialized for that.
Thanks.
I guess in your opinion, like, what do you predict about the future for both like Node.js and V8? Are they going to become obsolete anytime soon, or do you consider?
No. Everybody does Node. Like, it goes into enterprises, all these companies buying it up because they have all these JavaScript people. I mean, we all know JavaScript, right? We had to learn it at some point. So there's a huge amount of skilled workforce that can kind of use Node. And I mean, companies are short-sighted. They're just like, what's the easiest tool we can reach for that's going to cause the least inconvenience to us? And I think Node will go very fast. I mean, there's also use cases where Go is still strong. Smaller projects, anything below, I don't know, there's a cutoff point between 1,000 and 10,000 lines of code, where I think somewhere in between there, at the point where using JavaScript becomes inappropriate because it's just a mess to manage. Big JavaScript projects kind of tend to become very difficult, and where I think Go kind of overtakes the benefits. But if you just need something very fast, quick to write, Node is still awesome for that. Just shuffle data from A to B, simple task. Doesn't have to scale infinitely. Do that in Node. You can write that in a few hours. But I don't think it's going to be obsolete. It's going places. But I think so will Go. Go sees a lot of adoption.
How is since we only focused on MySQL, how does on the Node side of things, what is the support for other databases, and how mature is that in terms of in comparison to your MySQL library?
For Node or Go?
Node.
Other databases? I think there's client support for all databases right now. I haven't used most libraries except for them. I think I used some Couch and Mongo stuff because I had to. They work. I think there's enough community momentum into maintaining these libraries. So I think any database that has reasonable adoption these days, you're going to get a good connector in Node.js. That works. but it's open source. Sometimes you have to fix stuff. Anyway, if there's no more questions, let's drink beer. All of this is like my total personal bullshit opinion, so you should question all of it and draw your own conclusions. Thank you, guys.